All right, hi, I am Megan with the Girl Scouts of Central Maryland, and today we are going to be working on our Junior Space Science Investigator badge. So the very first thing that we're going to start with this badge is we are going to do a solar system walk. So what you're going to need to do is you're going to need to find a very large space in your neighborhood, and a bag of chalk, and probably an adult to go on this walk with you because we're going to be going quite a ways. So what we're going to do is we're going to see truly how far it is between the sun and hopefully Pluto. So what I'm going to do is we're going to need probably about a quarter mile of space. You could even do it with more space, and I'll include some instructions on how you can do this with about half a mile or even more. But for what I'm doing is I'm going to be using about a quarter of a mile of space. So we're going to go on a walk. We're going to start on our sun right here. And we are going to go and we're going to see how many steps between each planet there would be if we were going to scale it down a whole lot. So very first we're going to go on a walk to Mercury, and for our scale right here, the Mercury and the Sun are actually pretty close together. They're about 36 million miles apart, and in our scale that's going to be only 5 steps. So we're going to grab our gray piece of chalk and we're going to go ahead and go to Mercury because Mercury is kind of a grayish color. So we're going to go ahead and take 5 steps. 1, 2, 3, 4, 5. And at step 5 right here, I'm going to write down Mercury. Alright, so that seems pretty close, but we're going to see how far that really gets as we go along. The next planet that we're going to be going to is Venus, and Venus is kind of a light yellowish color, so I'm going to get my yellow chalk ready, and we're going to go about 4.5 steps. So they're pretty close together, but that's really going to be 67 million miles apart. So 1, 2, 3, 4, and a half. So right about here is going to be Venus. So, Venus is one of our neighbors. It is going to be, hi, how are you? We're going to be moving on to Earth next. And Earth is about 93 million miles away from the sun, but we're only going to be going 3.5 steps for this step. So you're going to go ahead, 1, 2, 3.5 is going to be our home and Earth. So right now it doesn't seem like I've gone a really far away from the sun to Earth, but in reality that is 93 million miles. So our next planet is our red planet. It is Mars, and we're going to be going 7 steps to Mars, and that is 142 million miles away from the sun. So we're going to go ahead and go 7 steps. 5, 6, 7 to Mars. So the next planet after Mars starts our gas giants. I'm going to have our cameraman come on and follow us up here because Jupiter is a very, very, very long way away from the sun. So all of these planets we've been doing under 10 steps to get to, but for Jupiter we're going to have to go 47.5 steps to get all the way up to Jupiter. And Jupiter is one of our gas giants, and it is kind of an orangish color, so I'm going to be ready with my orange chalk to go ahead and do 47.5 steps to Jupiter. So, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, and a half. All right. All right. So we can go ahead, and we're going to have my cameraman come over here. We're going to see if we can see the sun all the way over there. We're a long ways away from the sun. We are 484 million miles away from the sun. So So the sun's all the way over there, and as you're doing this, you might run into cars that are parking in their driveway. So if you're doing this in the street, make sure that you're paying attention to any cars around you. You can also do this on the sidewalk or maybe on a trail that has paved sidewalks. But after this, we're going to go ahead and go to Saturn, which is even further away. Saturn is 887 million miles away from the sun. So we're going to go ahead and take 56 steps. So let's go. 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 56. So Saturn is kind of a goldish color, so I'm going to go ahead and use my orange piece of chalk again, just to kind of represent that it is kind of goldish in color. Alright, so after Saturn, we're going to go ahead even further. We're going to go 1,783 million miles away from the sun to Uranus, which is a bluish colored planet. So I'm going to go ahead and get a blue piece of chalk out, and we're going to go ahead and go 142 and a half steps up to the next planet. So you can go ahead, keep on going. Steps. So we're going to stop right here, all the way up at the top of the hill. It's a really long way to go for Uranus. Alright, so the next planet that we're going to be traveling to is even further away. We're going to be going to Neptune, which is 2,794 million miles away from the sun. So if we want to go ahead, we can take a look. We started all the way down at the bottom of the hill. And go on down and take a look. We've made it quite a far ways away, but we still have 2 more places to stop. We're going to stop at Neptune, which is next, which is going to be 140 and a half steps away from Uranus. So hopefully we'll still have space to go. We're going to keep on going and see how far we make it. All right, so 140 and a half steps. 1, 2, 3, 4, 5, 6, 7, 8, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40 and a half. So now we made it all the way up to the top of the hill and we are at Neptune now. So I'm gonna go ahead. And with where we are in my neighborhood, we can't even see the sun. We've come up the hill and around the corner, we can't see where the sun was. And when I was growing up, it was considered a planet, but now it is a dwarf planet. But we're gonna go ahead and go all the way to Pluto, which is a total of 3,666,000,000 miles away from the sun. And we're gonna go another 121 steps. We're gonna see if we make it. Not quite sure, but let's see. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. We made it all the way to Pluto with very little space to go, so I'm going to go ahead and write Pluto. Hey. No bark. And apparently there are dogs on Pluto. Yes. All right. And
Pluto's
so
a Disney
that
dog.
is it. We've made it all the way to Pluto and we've done our planet walk. So with an adult, you can go ahead and go on a walk with a bag of chalk and see truly how far Pluto is from the sun. All right, thanks.
All right, so for part 2 of our space science investigator badge, we are going to be circling the sun. So what we're going to be doing is we're going to be figuring out how old we are on different planets. So what you're going to go ahead and do is, I have it open on the screen right now, we're going to go ahead to a resource from the Exploratorium, and I'll have the website linked up in the description for the video, so you can go ahead and easily access that. But what you're just simply going to do is you're going to go to this website and you are going to then be able to figure out how old you would be on each planet. So how many years it would be, because each planet has a different rotation as it goes around the sun. So we can go ahead and I'll show you. I'll go ahead and put in my birthday. And once we go ahead and put in my birthday, we're going to see how old I would be on different planets. I'd obviously be the oldest on Mercury because it has a much shorter rotation around the sun, so its year is much shorter than it would be on Earth. Or even if we go all the way down to Neptune and Pluto, I would not even be 1 year old for the number of times that Pluto has gone around the sun. It has not gone around the sun a complete time since I've been born. But you guys can go on ahead and check out what it would be for yourself for your birthday, other people in your family, and just kind of play around and see what you can kind of learn about different ages on planets. Right? All right, juniors, so for this step of our space science badge, we are going to be making a three-dimensional constellation. With these constellations, you're going to need a variety of materials. You're going to need either a piece of cardboard or a corkboard or foam or something that you can push something into. You can either use push pins, which I have. I'm going to explain to you why I'm not using the push pins that I have. Once we get kind of a little bit closer in, I'm actually going to be using some paper clips, but we'll go ahead and we'll kind of see what's happening with it, and you can choose to do what you'd like with it. You can also use sewing pins, or if you don't even have anything like that, you can then just make it with markers or crayons or coloring. But I also have, with all of my materials, is I found a constellation that I wanted to create. I decided for my constellation that I was going to create Ursa Major, which is the Big Dipper, or also known as the Big Bear. The constellations Ursa Major and Ursa Minor are actually a big and little bear. The word Ursa in Greek means bear, and major means big, minor means small. So what I'm going to do is, I already did a little bit of research, and you girls are going to have to probably do some research for this unless you want to go ahead and make Ursa Major with me, but I am going to encourage you to find a constellation that you really like to create for this project. So to start this project, I've done my research. I have learned all about Ursa Major on my own. I learned about the names of the stars, and I learned about the temperature of those stars that create Ursa Major. So what I'm going to do on my sheet, on my just piece of cardboard right here, I am going to go ahead and draw out my constellation. You can also print it out and put it on and kind of trace through that and draw it that way. I chose one that's a little bit easier to draw, so I'm just going to go ahead and draw Ursa Major on my board right here. I'm making sure that I include all of the stars that I'm going to be labeling, that are involved in it, and then I'm going to go ahead and just connect those dots. All right, and I'm also going to just go ahead and write the name of my constellation. Another way to extend this project, if you'd like, you could go ahead and paint your board black and draw it as if they were the stars. I don't have the right types of paints to do that, but that's something you can do to take it even a step further. So I went ahead, and I know my camera's backwards, but I went ahead and I drew my constellation right here. And throughout all of my research, I went ahead and I actually learned what all of the names of the stars in this constellation are. Ursa Major only has 1, 2, 3, 4, 5, 6, 7 stars that are the main stars of the constellation, so it wasn't too many to research. If you're looking up a constellation that has a lot more stars, some stars kind of don't have a name that might be easy for us to research or kind of include with this, but what you can do is you can include the main parts of the stars. So if you were to do Orion, the hunter, you could just include some of the main stars, which are the ones that make up Orion's belt, and some other of the main stars in that constellation. But as I did my research, I learned about all of the names of the stars. So the one at the very top of the handle of the Big Dipper is called, and I'm probably going to butcher some of these names pronouncing them, so I'm not sure if I'm correct with how I'm pronouncing them. They're all not in English, they're all Greek. So this first one is Alkaid, which is A-L-K-A-I-D, and Alkaid is a blue star. So when we're thinking about the temperature of stars, it's actually kind of opposite from what we think about for like the temperature of water. Blue typically means cold, and red typically means hot when we're looking at water temperatures, when we're labeling things, but with stars, it's exactly opposite. A blue star is the hottest type of star that there can be. Then there are kind of light blue stars, white stars, yellow stars, and then red stars. Red stars will be the coolest stars. And the stars have different temperatures depending on how old they are. So the older that a star gets, the more it dims and the different classification that it gets. So blue is the hottest, and Alkaid is a blue
star. So what I'm going to do, I'm using paper clips so that we can see them sticking up and sticking out. And I'm just going to go ahead and push that through my cardboard and wrap it around. And I want mine to stand up, so I'm going to go ahead and take a piece of tape and just secure it on the bottom of my board, just to kind of see that it's standing up, and we have a blue star right there. So you can start to see them show up. The next star that we have in Ursa Major is Mizar, M-I-Z-A-R. And it is also another blue star. There are a lot of blue stars in the constellation Ursa Major. So what I'm gonna go ahead and do is I'm gonna go ahead and put another one of my paper clips in. Again, if you have push pins of these colors, my push pins unfortunately were green, red, and yellow, and I didn't have quite the numbers that I needed to go ahead and do this with push pins. So Girl Scouts, we try and figure out and we use our resources, and I looked and I saw that I have a lot of different colored paper clips, so I thought that's a resource that I can use because we're stuck at home. We can't really go out to the store and pick up exactly what we might need. So I am using what I have in my home. The next star that we have is Alioth, A-L-I-O-T-H. And that is another blue star. So those three stars create the handle of our constellation for Ursa Major. And I'm gonna go ahead and poke that in. Give it a piece of tape to hold it nice, standing upright. And if you don't have like cardboard or anything like that, you can go ahead and you could do this on a cork board. You could use a box that you might have had something delivered in. And again, if you don't have those sorts of resources, you can go ahead and just do this on paper and do it as if you were labeling it in 3 dimensions. So we can see that I have these 3 taken care of, and now we're going to go on and move down to the cup portion of the Big Dipper. So the one star that is closest to the handle is called Megrez, M-E-G-R-E-Z. That is another blue star. So I'm going to go ahead and take just another blue paper clip and poke it on through. And there we have that. The one, we're going to go all the way down to the bottom side, following this line all the way down. This next star is Phecida, P-H-E-C-D-A. And this star is actually a blue-white star. So for my model to represent that it's blue and kind of a bluish white, it's kind of a little bit cooler than a true blue star. So I'm going to use 2 paper clips right next to each other, just like so, a blue and a white, to represent that it is not as hot as the other blue stars, but it's cooling off a little bit and becoming more closer to a white star, but it's not completely a white star just yet. So stars, it takes millions of years for them to change colors, but astronomers have done their research and studied over time to see how different stars are changing and how old they are based on the color and temperature that they are. So I've then added, so I have a blue and a white to represent that it is a bluish white star. We're going to go directly across on the bottom right there is Merak, M-E-R-A-K, which is another blue star. And I'm going to insert another blue paper clip in there to represent that it is a blue star. So as I do this, the very last star that we're going to label in our Ursa Major constellation is Dubhe. And Dubhe is the coolest star in the Ursa Major constellation, and it is actually a yellow star. It is the coolest and oldest star in this constellation, And I'm going to go ahead and label that it's D-U-B-H-E. And it is a yellow star, so I have a yellow paper clip to add in for this constellation. And go ahead and put a little piece of tape. All right, and so there you have it. I have all of my paper clips sticking up so that we can see the different stars that are labeled in my constellation. And again, you girls can go ahead and you can do Ursa Major, or you can go ahead and do some research and learn some new things about a constellation that you might not know as much about, and try and create your three-dimensional constellation.
All right, so for the fourth step of our Junior Space Science Investigator badge, we are going to be using tools to explore space. If you and your family have a telescope that you are able to use during this time to go out and explore the stars, that's a great resource to use. But for those that do not have resources like that, we can go ahead and we can find these tools online. One that I think is absolutely fantastic is, now that everybody is stuck inside and all of the museums are closed, a lot of museums have abilities for us to take virtual tours online. So the virtual tour that I think is really fantastic for us to take a look at is the Smithsonian National Air and Space Museum. So on this website, that'll again be linked up into the comments above with this badge, we'll be able to take a virtual tour of the Air and Space Museum. So what you can do is you can go on, take a tour. There is a map. I'm going to go ahead and just show you a little bit about how to navigate everything. We're going to go ahead and we're going to take a look at the Apollo area of the museum. So once you get in there, you can use your fingers or your mouse to guide yourself around. You can zoom in and look at different things. You can control the view of your angles and take a look and kind of just go through and explore this museum as if you would in person. And it's a really great resource that you can use to learn more about space.
All right, juniors, so now that we have done all of the steps of our space science badges, what you're going to do is I want you to go out with your family. I want you to share what you've learned. Maybe go out with your family, look at the night sky, teach a younger sibling a new fact that you've learned about the stars, or you can even you could take it even further and create something to share what you've learned. You can create a skit, a song, a poem, a poster, teaching everybody what you've learned. And if you do create something, a skit or something, be sure to record it and drop it down in the comments below so we can see what you all are doing with this space science badge that we've been working on. Have fun and happy star searching.